the universe should not exist. Not in the metaphysical sense, not in the philosophical sense of asking why there is something rather than nothing. In the physical sense, the specific universe that you inhabit, the universe with stars, planets, chemistry, biology, and consciousness, depends on a set of numerical values that are tuned with a precision so extreme, so improbable, and so far beyond the range of coincidence that the tuning constitutes one of the deepest unsolved problems in the history of physics. The problem is called fine-tuning, and it is not a philosophical argument. It is a measurement, a set of measurements, performed with the most precise instruments that physics has ever constructed, revealing that the fundamental constants of nature have values that fall within an extraordinarily narrow range that permits the existence of complex structures, and that any significant deviation from these values would produce a universe in which no stars form, no atoms are stable, no chemistry occurs, and no life of any kind is possible. The numbers are specific. Let us examine them. The first number is the strong nuclear force coupling constant, the parameter that determines the strength of the force that binds protons and neutrons together in atomic nuclei. The measured value of this constant is approximately 0.007, meaning that approximately 0.7% of the mass of two hydrogen atoms is converted into energy when they fuse into a deuterium nucleus, the first step in the nuclear fusion that powers every star in the universe. If the strong force coupling constant was 0.006 instead of 0.007, a change of approximately 14% deuterium would be unstable. The first step in nuclear fusion would fail. No star could convert hydrogen into helium. No star could shine. The universe would be a cold, dark, structureless expanse of hydrogen gas, devoid of the energy sources that chemistry and biology require. If the strong force coupling constant was 0.008 instead of 0.007, a change of approximately 14% in the other direction, two protons would bind directly to each other without the need for a neutron. All the hydrogen in the early universe would have been converted into helium in the first few minutes after the Big Bang. No hydrogen would remain. No water could form. No organic chemistry, which depends on the unique bonding properties of carbon in the presence of hydrogen and oxygen, could occur. The universe would be a uniform sea of helium, devoid of the chemical diversity that life requires. The window is 14% in either direction. Outside that window, no stars, no chemistry, no life. The strong force coupling constant falls within the window, not at the edge, not at the center, but at the specific value that produces the specific nuclear physics, that the specific chemistry of the specific biology of the specific consciousness that is reading these words requires. The physicist John Barrow at the University of Cambridge has described the strong force fine-tuning with an analogy that captures its precision. Imagine a radio dial that spans the entire width of the observable universe, 93 billion light-years. The tuning required for the strong force coupling constant is equivalent to setting the dial to within 1 millimeter of the correct position. A deviation of 1 millimeter on a dial that spans the cosmos would produce a universe without nuclear physics, without stellar energy, and without the chemical elements that complex structures require. The strong force fine-tuning is not the most extreme tuning in the catalogue. It is merely the most easily visualized. The tunings become progressively more extreme as we move from the nuclear scale to the cosmological scale, from the forces that operate within the atomic nucleus to the parameters that govern the structure and the fate of the universe as a whole. The second number is the electromagnetic force coupling constant, the fine structure constant, alpha, whose value is approximately 1/137. The fine structure constant determines the strength of the electromagnetic interaction between charged particles, the force that holds electrons in orbit around nuclei, that holds atoms together in molecules, and that holds molecules together in the structures of the physical world. If the fine structure constant was significantly larger, the electromagnetic repulsion between protons in the nucleus would overpower the strong force, and no nucleus heavier than hydrogen could exist. No carbon, no oxygen, no periodic table, no chemistry. If the fine structure constant were significantly smaller, the electrons would not be bound tightly enough to their nuclei to form stable atoms, and the matter of the universe would be a diffuse, structureless plasma incapable of forming the specific, stable, chemically active atoms that the periodic table contains. The physicist Richard Feynman described the fine structure constant as one of the greatest damn mysteries of physics, a number that has no known theoretical explanation, that cannot be derived from any deeper principle, and whose specific value appears to be a brute fact of the universe that the physics must accept without explanation. But the value is not arbitrary. It is precisely the value that produces stable atoms, stable molecules, and the specific chemistry that complex structures require. The physicist Freeman Dyson demonstrated an additional fine-tuning of the electromagnetic interaction that is often overlooked. The specific value of the fine structure constant determines the specific pattern of atomic energy levels that produces the specific spectral lines that allow atoms to interact with light in the specific ways that chemistry requires. The photosynthesis that powers the biosphere depends on the specific absorption properties of the chlorophyll molecule properties that are determined by the specific energy levels of the atoms in the molecule, which are determined by the specific value of the fine structure constant. A different value of alpha would produce different energy levels, different spectral properties, and different chemistry. Chemistry that might not support the specific molecular mechanisms that biological energy harvesting requires. The physicist Victor Stenger, a prominent skeptic of fine-tuning arguments, argued that many of the constants could be varied by larger ranges than the fine-tuning proponents claim, and still produce a universe capable of some form of complexity. Stenger's point is valid but limited. The question is not whether some form of complexity could exist with different constants, but whether the specific complexity that the observed universe displays, the specific chemistry, the specific biology, the specific consciousness could exist with different constants. And the answer, for the constants we are examining, is no. The specific constants produce the specific universe. Different constants would produce a different universe, a universe that might contain some form of complexity, but that would not contain the specific form of complexity that you are. The third number is the ratio of the electromagnetic force to the gravitational force, a ratio of approximately 10 to the 36th power. The electromagnetic force is approximately 1,000 trillion times stronger than the gravitational force. This enormous ratio is responsible for the specific structure of the universe at every scale. If the ratio was smaller, if gravity was stronger relative to electromagnetism, stars would be smaller, would burn hotter, and would exhaust their fuel in millions of years rather than billions, producing a universe in which the timescales of stellar evolution are too short for biological evolution to occur. The Sun has burned for 5 billion years, providing the stable energy source that biological evolution required to produce the complexity that the present moment displays. A universe with a smaller electromagnetic to gravitational ratio would not have provided this time. If the ratio were larger, if gravity were weaker relative to electromagnetism, stars would be larger, would burn cooler, and would not produce the heavy elements that planetary formation and biological chemistry require. The carbon, oxygen, nitrogen, and iron that constitute your body were produced in the cores of massive stars that exploded as supernovae billions of years ago. A universe with a larger ratio would not have produced these elements in the quantities that chemistry and biology require. The physicist Brandon Carter, who first formulated the anthropic principle in 1973, demonstrated that the electromagnetic to gravitational ratio has additional fine-tuning consequences for the structure of stars. Carter showed that the ratio determines whether stars can be convective, whether the energy produced in their cores can be transported to their surfaces by the churning, circulating motion of the stellar material. Convection is essential for the magnetic activity that drives stellar winds, that produces the planetary environments that life requires, and that distributes the heavy elements produced by nuclear fusion throughout the interstellar medium. A slightly different ratio would produce stars that are either entirely convective, producing violent, unstable environments, or entirely radiative, producing insufficient mixing of the stellar material. In either case, failing to produce the specific stellar environments that planetary formation and biological evolution require. The ratio also determines the mass range of stars that can exist. Stars below approximately 0.08. Solar masses cannot sustain hydrogen fusion. They are brown dwarfs. Failed stars that glow faintly in the infrared. Stars above approximately 150 solar masses are unstable. Their radiation pressure overwhelms the gravitational binding and tears them apart. The specific mass range between these limits, the range that produces main sequence stars capable of sustaining nuclear fusion for billions of years, is determined by the electromagnetic to gravitational ratio. A different ratio would produce a different mass range, and potentially no range at all that is compatible with the stable, long-lived, element-producing stars that the chemistry and biology of the observed universe require. The fourth number is the cosmological constant, the energy density of the vacuum, the dark energy that drives the accelerating expansion of the universe. The measured value of the cosmological constant is approximately 10 to the minus 122 inches, natural units. A number so small that it is effectively zero, but that is not exactly zero, and the precision of the tuning is extraordinary. If the cosmological constant were larger by a factor of approximately 10 to the 120th still, an inconceivably small number, by everyday standards the expansion of the universe would have been so rapid that no galaxies, no stars, and no planets could have formed. The matter would have been dispersed before gravity could collect it into the structures that the cosmic web displays. The universe would be a cold, empty, featureless void expanding forever, producing nothing, containing nothing. If the cosmological constant were negative and of comparable magnitude, the universe would have collapsed back on itself within a fraction of a second. A big crunch that would have ended the universe before any structure could form. The cosmological constant is tuned to 120 decimal places. 120 decimal places. This is the most precise tuning in the known universe, a precision so extreme that the physicist Leonard Susskind has described it as the worst fine-tuning problem in all of physics. The vacuum energy must be almost exactly zero, but not exactly zero, and the specific non-zero value that it has is the specific value that produces a universe that expands slowly enough for galaxies to form, but fast enough to prevent the universe from collapsing back on itself. The cosmological constant problem, the discrepancy between the theoretical prediction of the vacuum energy, which is 120 orders of magnitude larger than the observed value, and the measured value is widely regarded as the most significant unsolved problem in theoretical physics. The theoretical calculation uses quantum field theory to sum the zero-point energies of all the quantum fields, and the sum is enormous. The observed value is tiny. Something is cancelling almost all of the theoretical vacuum energy, leaving only the minuscule residual that drives the observed cosmic acceleration. What performs the cancellation? No one knows. The physicist Steven Weinberg made a remarkable prediction in 1987 based on the fine-tuning of the cosmological constant. Weinberg argued that if the cosmological constant were much larger than the value required for galaxy formation, no galaxies would form, no stars would form, no observers would exist, and no one would be measuring the cosmological constant. Therefore, Weinberg predicted, the cosmological constant should be just small enough to permit galaxy formation, and the observed value should be close to the maximum value consistent with the existence of galaxies. When the cosmological constant was measured for the first time in 1998, 11 years after Weinberg's prediction, the measured value was remarkably close to Weinberg's predicted maximum. The prediction is one of the most impressive examples of fine-tuning reasoning producing a correct, quantitative, experimentally confirmed prediction. The fifth number is the one that the physicist Fred Hoyle discovered, and that converted him from an atheist to a believer in cosmic intelligence. Hoyle was investigating the nuclear synthesis of carbon, the element on which all known life is based. Carbon is produced in the cores of stars through the triple alpha process, the fusion of 3 helium nuclei into a single carbon nucleus. The process requires 2 steps. First, 2 helium nuclei fuse to form beryllium-8. Then, a 3rd helium nucleus fuses with the beryllium-8 to form carbon-1,2. The problem is that beryllium-8 is extraordinarily unstable. It exists for only approximately 10 to the minus 16 seconds before decaying back into 2 helium nuclei. The probability that a 3rd helium nucleus will collide with the beryllium-8 during this tiny window is vanishingly small, too small to produce the carbon that the universe abundantly contains. Hoyle recognized that the only way to produce carbon in the observed quantities was through a resonance, a specific energy level of the carbon, 1,2, nucleus, that dramatically enhances the probability of the triple alpha fusion. Hoyle predicted, on the basis of the observed abundance of carbon alone, that the carbon 1,2 nucleus must have a specific excited state at an energy of approximately 765 mega-electron volts, an energy that is almost exactly equal to the combined energy of the beryllium-8 nucleus and the helium nucleus that fused to form it. The resonance would amplify the fusion rate by a factor of approximately 10 million, producing the carbon abundances that the observations require. The prediction was extraordinary. Hoyle was predicting a specific nuclear energy level, a property of a specific atomic nucleus, on the basis of the observed abundance of carbon in the universe. The prediction was confirmed experimentally by William Fowler at Caltech, who measured the carbon 1,2 nucleus and found the predicted energy level at exactly the energy that Hoyle had specified. Fowler's measurement earned him the Nobel Prize in 1983, but Hoyle's discovery went deeper than the prediction. Hoyle recognized that the carbon resonance is itself fine-tuned. If the energy level were slightly higher by approximately 4%, the resonance would not match the beryllium-8 plus helium energy, and the triple alpha process would fail. No carbon, no organic chemistry, no life. If the energy level were slightly lower, the carbon that was produced would be efficiently converted into oxygen through a subsequent resonance in the oxygen-1,6 nucleus, leaving insufficient carbon for life. The carbon resonance is tuned to a precision of approximately 4%, and the oxygen resonance is tuned to avoid destroying the carbon that the carbon resonance produces. Hoyle described his reaction to this discovery with words that have become famous in the history of science. A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with the physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. Hoyle was not a religious man. He was not making a theological argument. He was reporting his scientific assessment of the evidence The fine-tuning of the carbon resonance is so specific, so precise, and so improbable that the most natural explanation is that the tuning was performed by an intelligence, a super-intellect, that monkeyed with the physics to produce the specific nuclear energy levels that carbon-based life requires. Hoyle's discovery of the carbon resonance is significant not only for what it revealed about the fine-tuning, but for how it was discovered. Hoyle did not discover the resonance by studying the carbon nucleus. He discovered it by reasoning backward from the existence of carbon in the universe, by asking what nuclear physics would be required to produce the observed abundances, and then predicting the specific nuclear properties that the required physics demands. The reasoning is anthropic. It starts from the existence of observers and works backward to the physical conditions that the existence of observers requires. And the reasoning produced a correct prediction, a prediction that was confirmed by experiment, and that earned Hoyle's collaborator the Nobel Prize. The success of Hoyle's anthropic reasoning raises a question that has haunted physics since the 1950s. Is the fine-tuning evidence of design, or is it merely the inevitable consequence of the fact that we exist? If the constants were different, we would not be here to observe them. The fact that we are here to observe them means that the constants must be within the range that permits our existence. Is the fine-tuning, then, merely a selection effect, the trivial observation that the constants are compatible with our existence, which they must be because we exist? The answer is no, or at least, the answer is not that simple. The selection effect explains why we observe life-compatible constants rather than life-incompatible constants. But it does not explain why the constants are fine-tuned, why the range of life-compatible values is so extraordinarily narrow, why the precision of the tuning is so extreme, and why the specific values that the constants have are the specific values that produce the maximum diversity of complex structures. The selection effect explains the what we observe life-compatible constants. It does not explain the why. The constants are tuned to an extraordinary precision that the selection effect alone does not require. The sixth number is the density parameter of the universe omega, the ratio of the actual density of the universe to the critical density that determines the universe's geometry. If omega is exactly 1, the universe is geometrically flat, Euclidean, infinite, and balanced on the knife edge between eternal expansion and eventual collapse. If omega is greater than 1, the universe is positively curved and will eventually collapse. If omega is less than 1, the universe is negatively curved and will expand forever at an accelerating rate. The measured value of omega is 1 to within 1%. The universe is flat, and the flatness is itself a fine-tuning. At the moment of the Big Bang, the density of the universe had to be tuned to the critical density with a precision of approximately 1 part in 10 to the 60th. A deviation of 1 part in 10 to the 60th, 1 trillionth of a 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 percent, would have produced a universe that either collapsed within seconds or expanded so rapidly that no structures could form. The physicist Roger Penrose has calculated the probability that the universe's initial conditions would produce by chance the specific low-entropy state that the observed universe requires. Penrose's calculation yields a probability of 1 part in 10 to the power of 10 to the 123rd, a number so inconceivably small that Penrose describes it as the most extreme fine-tuning in all of physics. The number has more digits than the number of particles in the observable universe. It has more digits than the number of possible quantum states of the observable universe. It is, by any reasonable standard, indistinguishable from zero. Penrose's number is so large that it is difficult to convey its magnitude. If you wrote a 0 on every atom in the observable universe, approximately 10 to the 80th atoms, you would have written 10 to the 80th zeros. The number of zeros in Penrose's probability is not 10 to the 80th. It is 10 to the 123rd, a number that is 10 to the 43rd times larger than the number of atoms in the observable universe. You could not write Penrose's number if every atom in the observable universe were a zero. You could not write Penrose's number if every atom in a trillion observable universes were a zero. The number is beyond comprehension, and the probability that the universe's initial conditions would produce, by chance, the specific low-entropy state that the observed universe requires is 1, divided by this number, a probability that is, for all practical and impractical purposes, 0. Penrose himself has drawn a strong conclusion from his calculation. The Creator's purpose in creating the universe was extremely precise. Penrose is not a religious man in the conventional sense. He does not identify with any organized religion, but he has stated, repeatedly, that the extreme precision of the initial conditions suggests a purposiveness, a directedness, a specificity, a selection that the language of chance cannot adequately describe. The physicist Paul Davies has summarized the fine-tuning evidence with characteristic clarity. The impression of design is overwhelming. Davies is not a creationist. He is not an advocate of intelligent design in the biological sense. He is a physicist who has examined the numerical values of the fundamental constants and who has concluded that the specific values, the specific, precise, extraordinarily narrow ranges within which the constants fall, produce an impression that is difficult to describe in any language other than the language of design. The fine-tuning is not limited to the 6 numbers we have examined. The physicist Martin Rees, the Astronomer Royal of the United Kingdom, identified 6 numbers in his book Just 6 Numbers that he argued are sufficient to determine the large-scale structure of the universe. But subsequent analysis has identified dozens of fine-tuned parameters, including the masses of the quarks, the mass of the electron, the strength of the weak force, the number of spatial dimensions, the number of generations of matter particles, and the specific pattern of symmetry breaking that the Higgs mechanism produces. Each parameter falls within a narrow range that permits complex structures, and the combined probability that all the parameters would simultaneously fall within their respective ranges, the probability that the universe would, by chance, hit every target simultaneously, is a number that approaches 0, with a ferocity that makes the individual fine-tunings look generous. The physicist Luke Barnes at Western Sydney University has conducted the most comprehensive analysis of the fine-tuning evidence, examining over 200 parameters and calculating the fraction of the parameter space that permits complex structures. Barnes's conclusion is stark. The life-permitting region of parameter space is an extraordinarily small fraction of the total, a fraction so small that the probability of hitting it by chance is, for practical purposes, 0. The fraction is not small in the way that a needle in a haystack is small. It is small in the way that a single atom in the observable universe is small relative to the universe, except that the ratio is even more extreme, because the parameter space has hundreds of dimensions, and the life-permitting region is a tiny island in a vast, life-hostile ocean. The philosopher Robin Collins at Messiah University has formalized the fine-tuning argument in Bayesian terms. Collins argues that the probability of the observed fine-tuning given a designer is much higher than the probability of the observed fine-tuning given chance, because a designer would have reason to produce life-compatible constants, while chance would not. The Bayesian analysis does not prove that a designer exists, but it establishes that the fine-tuning evidence is more probable on the design hypothesis than on the chance hypothesis, and that the rejection of the design hypothesis in favor of the chance hypothesis requires an explanation for the fine-tuning that chance alone does not provide. The contemplative traditions have been describing the fine-tuning in their own languages for millennia. In Hinduism, the concept of Rita, the cosmic order, the fundamental principle of harmony and regularity that governs the universe, describes a reality in which the numerical relationships between the forces, the elements, and the cosmic structures are not accidental but ordained. The Rig Veda's hymn to Rita declares that the cosmic order precedes the gods, that the order is more fundamental than the deities who operate within it, and that the order is the foundation on which the entire cosmic structure is built. The fine-tuning of the constants is the modern physics confirmation of Rita. The numerical order that governs the universe is specific, precise, and foundational, and the cosmic structures that the order produces, the stars, the planets, the living beings, are the consequences of the order, not the causes of it. The concept of Rita evolved into the later Hindu concept of Dharma, the cosmic law that governs not only the physical relationships between forces and elements, but the moral and spiritual relationships between actions and consequences. The fine-tuning in the Hindu framework is not merely physical, it is moral. The numerical values of the constants are set not only to produce physical structures, but to produce the specific moral and spiritual environment that the soul's development requires. The universe is not merely a machine that happens to support life. It is a school, a specifically, precisely, intentionally designed environment for the development of consciousness, from ignorance to enlightenment, from bondage to liberation, from the surface identification with the changing to the source identification with the unchanging. The Isha Upanishad opens with a declaration that connects the cosmic order to the moral order. All this, whatever moves in this moving world, is pervaded by the Lord. Therefore find your enjoyment in renunciation. Do not covet what belongs to others. The cosmic order, Rita, Dharma, and the moral order, renunciation, non-coveting, are not separate domains. They are aspects of a single, unified, divinely ordained structure that the fine-tuning reveals at the physical level and that the ethical teaching reveals at the moral level. In Buddhism, the concept of Dharma in its cosmological sense, the law that governs the arising and passing of all phenomena, describes a universe that is not random but lawful, not chaotic but ordered, not arbitrary but structured by principles that produce specific, predictable, reliable outcomes. The fine-tuning of the constants is the quantitative expression of the Dharma, the specific numerical values that the laws require in order to produce the specific cosmic outcomes that the Dharma describes. In Christianity, the concept of the Logos, the divine reason, the rational principle that structures the universe, has been interpreted since the patristic period as the foundation of the cosmic order. The Church, Father Clement of Alexandria, described the Logos as the architect of the world, the divine intelligence that designed the cosmic structure with the specific numerical relationships that the fine-tuning reveals. The fine-tuning is, in the Christian framework, the fingerprint of the Logos, the numerical signature of the divine architect, inscribed in the specific values of the fundamental constants. The Taoist tradition describes the cosmic order through the concept of the Tao, the nameless, formless, all-encompassing principle from which the specific, named, formed structures of the world arise. The Tao Te Ching states, "The Tao gives birth to one gives birth to two gives birth to three gives birth to the 10,000 things." The sequence is a fine-tuning sequence, the progression from the single, unifying principle to the specific, differentiated structures that the principle produces through the specific numerical relationships, 1, 2, 3, that determine the specific outcome, the 10,000 things. The specific numbers matter. Different numbers would produce different outcomes, and the specific numbers that the Tao employs are the specific numbers that produce the specific world that the Tao intends. The Jewish Kabbalistic tradition describes the creation through the 10 Sephirot, 10 divine emanations, whose specific numerical relationships determine the specific structure of the created world. The Sephirot are not arbitrary. They are precisely ordered, each one connected to the others through specific paths, specific relationships, and specific proportional ratios that the Kabbalistic tradition maps with extraordinary mathematical precision. The tree of life is a fine-tuning diagram, a map of the specific numerical relationships that produce the specific cosmic structure that the creation displays. The question of why the constants have the values they have, the question of whether the fine-tuning is the product of chance, of necessity, of a multiverse, or of a cosmic intelligence, is the question that the next stage of this investigation will pursue. Because the fine-tuning is not merely a curiosity of the numerical values, it is a confrontation between the universe's apparent design and the scientific method's commitment to natural explanation, between the overwhelming impression of purpose and the disciplined refusal to invoke purpose without evidence, and between the numbers that should not work and the universe that, against all probability, does. We have established that the fundamental constants of nature are fine-tuned to a precision that is, by any reasonable standard, extraordinary, that the strong force, the electromagnetic force, the gravitational force, the cosmological constant, the carbon resonance, and the density parameter all fall within narrow ranges that permit the existence of complex structures, and that any significant deviation from these values would produce a universe in which no stars form, no chemistry occurs, and no consciousness arises to ask why the numbers have the values they have. The question is, why? Why do the constants have these specific values? Why is the universe tuned to produce complexity and consciousness? And the physics provides exactly 4 possible answers. The first is chance, the second is necessity, the third is the multiverse, and the fourth is design. Each answer has specific strengths, specific weaknesses, and specific implications for the nature of reality. And the question of which answer is correct, or whether the correct answer is a combination of several, is one of the most consequential questions in the history of human thought. The first answer is chance. The chance hypothesis says the constants have their values by accident. There is no reason. There is no explanation. The constants could have had any values, and they happen to have the values that permit life. We are here to observe these values because if the values had been different, we would not be here. The fine-tuning is a brute fact, an unexplained datum that the physics must accept without further justification. The chance hypothesis has the virtue of simplicity. It does not require any mechanism beyond the physical constants themselves. It does not invoke unobservable entities, no multiverse, no designer, no deeper principle. It simply says, the constants are what they are, and we are fortunate. But the chance hypothesis has a devastating weakness, the probability. The combined probability that all the fine-tuned constants would simultaneously fall within their life-permitting ranges by chance is a number that approaches 0 with a severity that makes the chance hypothesis extraordinarily difficult to maintain. Penrose's calculation of the probability of the universe's initial conditions, 1 part in 10 to the power of 10 to the 123rd, is a number so small that calling it improbable understates the case by a factor that is itself incomprehensibly large. The chance hypothesis asks us to accept that the most improbable event in the conceivable history of all conceivable universes has occurred, and that no explanation is required. The physicist Lee Smolin at the Perimeter Institute has attempted to quantify the probability more precisely. Smolin calculated the probability that a randomly selected universe would produce at least one star, the minimum requirement for a universe that could support any form of complexity. His result, approximately 1 part in 10 to the 229th. The probability of a star-producing universe is, by this calculation, incomprehensibly small, so small that the chance hypothesis requires us to accept that we are the beneficiaries of the most improbable accident in the space of all possible accidents. The statistician William Dembski has formalized the argument against chance through what he calls the universal probability bound, the probability below which an event can be regarded as essentially impossible, given the total number of opportunities for the event to occur in the entire history of the observable universe. Dembski calculates the universal probability bound as approximately 1 part in 10 to the 150th, the product of the number of elementary particles in the observable universe, approximately 10 to the 80th, the number of state transitions per second per particle, approximately 10 to the 45th, and the age of the universe in seconds, approximately 10 to the 25th. Any event with a probability below this bound is, by Dembski's criterion, beyond the reach of chance, regardless of how many times the opportunity for the event occurs. The probability is too small for the event to happen even once in the entire history of the observable universe. The fine-tuning probabilities that we examined in the previous stage, Penrose's 1 part in 10 to the 10 to the 123rd, the cosmological constant's 120 decimal places of tuning, the combined probability of all the independently tuned parameters are all incomprehensibly below Dembski's universal probability bound. The chance hypothesis is not merely improbable, it is, by the standards of the universal probability bound, impossible, not in the logical sense, it is not self-contradictory, but in the statistical sense, the probability is too small for the event to be expected in any finite universe, in any finite time, under any finite set of conditions. The philosopher John Leslie illustrated the problem with an analogy. Imagine that you are facing a firing squad of 50 expert marksmen. They all fire, and they all miss. You survive. The chance hypothesis says no explanation is required. The marksmen fired, they missed, you are alive, and the probability of their missing is irrelevant because you are here to observe the outcome. But this response is clearly inadequate. The survival demands an explanation: either the marksman missed on purpose, design, or there were many executions, and you are observing the one in which the marksman happened to miss multiverse. The mere fact that you are alive to observe the outcome does not explain the outcome. It merely identifies you as the observer of an outcome that still requires explanation. The second answer is necessity. The necessity hypothesis says the constants have their values because they could not have had any other values. The values are determined by a deeper physical principle, a principle that the current physics has not yet discovered, but that, when discovered, there will show that the constants are not free parameters that could have taken any value, but are fixed, mathematically necessary consequences of a deeper theory. The necessity hypothesis is the most scientifically conservative answer. It does not invoke unobservable entities. It does not abandon the scientific commitment to natural explanation, and it holds out the promise of a deeper understanding, a theory of everything that would explain the values of the constants from first principles and that would eliminate the fine-tuning problem by showing that the fine-tuning is an illusion produced by the incompleteness of the current theory. The physicist Albert Einstein expressed this hope throughout his career. What I am really interested in is whether God had any choice in creating the universe. Einstein's question is the necessity hypothesis in its purest form. Are the constants of nature necessary, determined by the mathematical structure of reality with no room for variation? Or are they contingent values that could have been different and that require an explanation for their specific values? The physicist Murray Gell-Mann described the necessity hypothesis as the search for the total principle, the single, all-encompassing, mathematically inevitable principle from which every physical law, every constant, and every feature of the observable universe follows with logical necessity. The total principle would be the theory of everything in its strongest form, not merely a theory that describes all the forces and particles, but a theory that explains why these specific forces, these specific particles, and these specific constants are the only ones that are logically possible. The quest for the total principle has produced some of the deepest insights in the history of physics. Einstein's general relativity derives the gravitational constant from the geometry of space-time, showing that gravity is not an independent force with an arbitrary strength, but a geometric property of space-time whose specific form is determined by the principle of general covariance. The Standard Model derives the masses of the W and Z bosons from the Higgs mechanism, showing that the specific masses are not arbitrary, but are determined by the symmetry-breaking pattern of the electroweak interaction, and the quantum mechanical commutation relations derive the energy levels of the hydrogen atom from the uncertainty principle, showing that the specific spectral lines are not arbitrary, but are determined by the mathematical structure of quantum mechanics. Each of these derivations reduces a previously arbitrary constant to a necessary consequence of a deeper principle. The hope of the necessity hypothesis is that every constant will eventually be reduced in this way, that the total principle will explain every value, eliminate every arbitrariness, and show that the fine-tuning is not a tuning at all, but a mathematical inevitability. The necessity hypothesis faces a specific challenge: the string theory landscape. The physicist Leonard Susskind and the cosmologist Raphael Bousso demonstrated in 2000 that string theory, the most developed candidate for the theory of everything, does not produce a unique set of physical constants. Instead, it produces a landscape of approximately 10 to the 500th possible configurations, each one corresponding to a different set of physical constants, a different set of particle masses, a different set of force strengths, and a different low-energy physics. The landscape is not a small set of possibilities. It is an astronomically vast set, vastly larger than the number of atoms in the observable universe, vastly larger than the number of quantum states that the observable universe can contain. If string theory is correct, and if the landscape is real, then the constants are not necessary. They are contingent one set of values among 10 to the 500th possible sets, selected not by mathematical necessity, but by the specific vacuum state that the universe happens to occupy. The necessity hypothesis fails in the string theory landscape because the landscape provides too many possibilities, too many possible sets of constants, too many possible physics, and too many possible universes for the specific constants of our universe to be necessary. The landscape has a specific structure that is relevant to the fine-tuning debate. Each point in the landscape, each vacuum state corresponds to a specific set of physical constants. The vacuum states are separated by energy barriers, potential walls that the universe must tunnel through to transition from one vacuum to another. The cosmological history of a specific universe depends on which vacuum state the universe occupies, how stable the state is, and whether the state can decay into a lower energy state through quantum tunneling. The landscape's vastness means that among the 10 to the 500th possible configurations, some will, by pure chance, have constants that permit complex structures. The question is whether the existence of these life-compatible configurations in the landscape constitutes an explanation for the fine-tuning, or merely relocates the mystery. The landscape explains why life-compatible constants exist among the possible configurations, but it does not explain why our universe occupies a life-compatible configuration rather than one of the vastly more numerous life-incompatible configurations. The landscape provides the menu. It does not explain the order. The physicist David Gross, who shared the Nobel Prize for the discovery of asymptotic freedom, has argued that the landscape may be an artifact of our incomplete understanding of string theory, that a more complete formulation may eliminate most of the landscape's vacua and produce a smaller, possibly unique, set of consistent configurations. Gross's hope is the necessity hypothesis applied to string theory. The correct theory, when fully understood, may show that the constants are necessary after all, but the hope has not been realized. The landscape remains vast, the constants remain contingent, and the necessity hypothesis remains, for now, a promissory note rather than a delivered explanation. The third answer is the multiverse. The multiverse hypothesis says the constants have their values because all possible values are realized in different regions of a vast, possibly infinite ensemble of universes, each with its own set of physical constants. Our universe has life-compatible constants because we could only exist in a universe with life-compatible constants. The fine-tuning is a selection effect. We observe fine-tuned constants because fine-tuned constants are the only constants that produce observers. The multiverse hypothesis is not science fiction. It arises naturally from two of the most well-established theoretical frameworks in modern physics: eternal inflation and the string theory landscape. Eternal inflation, proposed by Alan Guth, André Linde, and Alex Vilenkin in the 1980s, describes a process in which the inflationary expansion of the early universe does not end everywhere simultaneously. Instead, inflation ends in local regions, bubble universes, while continuing in the spaces between the bubbles. The process is eternal. The inflating space between the bubbles expands faster than the bubbles form, producing an ever-growing collection of bubble universes embedded in an eternally inflating background. Each bubble universe undergoes its own Big Bang, its own cooling, its own structure formation, and each bubble can have different physical constants, depending on the specific vacuum state that the bubble occupies in the string theory landscape. The combination of eternal inflation and the string theory landscape produces a multiverse of staggering proportions. The number of bubble universes is infinite. The number of different sets of physical constants is 10 to the 500th, and the probability that at least one bubble universe has the specific set of constants that permits complex structures and consciousness is effectively 1, because the number of bubbles is infinite and the number of possible constant sets is finite. In an infinite collection of universes sampling 10 to the 500th possible configurations, every configuration is realized, including the configuration that produces the specific universe that you inhabit. The physicist Max Tegmark has classified the multiverse into 4 levels. Level I is the spatial multiverse, other regions of our own universe beyond the cosmic horizon. Level 2 is the inflationary multiverse, the bubble universes that eternal inflation produces. Level 3 is the quantum multiverse, the branches of the wave function that the many worlds interpretation describes. And level 4 is the mathematical multiverse, the totality of all mathematically consistent structures, each one constituting a complete, self-contained reality. Each level provides a different type of explanation for the fine-tuning. Level I provides spatial variation, different regions of space with different local conditions. Level 2 provides parametric variation, different bubble universes with different fundamental constants. Level 3 provides quantum variation, different branches with different quantum outcomes. And Level 4 provides structural variation, different mathematical structures with different physical laws entirely. The most relevant level for the fine-tuning debate is Level 2, the inflationary multiverse, with its parametric variation. This is the level at which different bubble universes have genuinely different fundamental constants, genuinely different particle physics, and genuinely different chemistry. And this is the level at which the anthropic selection effect operates. Among the infinite collection of Level 2 bubbles, some will have life-compatible constants, and observers will necessarily find themselves in those bubbles. The multiverse hypothesis has the strength of being derived from established physics rather than invented to solve the fine-tuning problem. Eternal inflation is a consequence of well-established inflationary cosmology. The string theory landscape is a consequence of well-established string theory, and the combination of the two produces the multiverse as a natural, unforced consequence of the physics, not as an ad hoc hypothesis designed to explain the fine-tuning, but as a prediction of the theories that the physics independently supports. But the multiverse hypothesis faces serious objections. The first objection is that the multiverse is unobservable. The other bubble universes are, by definition, causally disconnected from our universe. No signal, no particle, no information can travel from one bubble to another. The multiverse cannot be directly detected, directly measured, or directly confirmed by any experiment that could be performed from within our universe. The multiverse is, in the strict sense, unfalsifiable, and an unfalsifiable hypothesis is, by the standards of the scientific method, not a scientific hypothesis at all. The physicist Paul Steinhardt, one of the original architects of inflationary cosmology, has become one of the multiverse's most vocal critics. Steinhardt argues that the multiverse explains everything and therefore explains nothing, that a theory that predicts every possible set of physical constants makes no specific prediction about the constants of our universe and therefore has no explanatory power. The multiverse does not explain why our universe has these specific constants. It explains why some universe has these constants, but that is a different question, and the answer to it provides no information about the specific universe that we inhabit. The physicist Sabine Hossenfelder has raised a related criticism. The multiverse hypothesis undermines the predictive power of physics. If every possible set of constants is realized somewhere in the multiverse, then the physics can never predict the specific constants of our universe, because any prediction would be compatible with some region of the multiverse. The multiverse, Hossenfelder argues, is not a theory. It is the abdication of theory, the surrender of the scientific goal of prediction, in favor of a framework that accommodates any observation without being tested by any observation. The defenders of the multiverse respond that the multiverse is not intended to predict the specific constants. It is intended to explain why the constants are fine-tuned, and the explanation is the selection effect. We observe fine-tuned constants because we exist, and we exist because the constants are fine-tuned. The explanation is not predictive, but it is explanatory. It provides a framework within which the fine-tuning is expected, rather than surprising. The debate between the critics and the defenders of the multiverse is, in essence, a debate about what counts as a scientific explanation. The critics demand prediction, the defenders accept selection, and the resolution of the debate depends on which standard of explanation the scientific community ultimately adopts, a question that is as much philosophical as it is physical. The second objection is the measure problem. In an infinite multiverse, every event occurs infinitely many times. The probability of any specific event, including the existence of a universe with our specific constants, depends on how the infinite collection of events is counted. Different counting methods produce different probabilities, and no counting method has been identified that produces unambiguous, well-defined probabilities for the specific constants of our universe. The multiverse cannot, even in principle, assign a specific probability to the fine-tuning, and a theory that cannot assign probabilities cannot be tested. The physicist Roger Penrose has raised a specific objection to the multiverse as an explanation for the fine-tuning of the initial conditions. Penrose notes that his calculation of the improbability of the initial conditions 1 part in 10 to the 10 to the 123rd is so extreme that the multiverse does not help. Even if the multiverse contains 10 to the 500th different vacuum states, the number of states is vanishingly small compared to the improbability of the initial conditions. The multiverse would need to contain not 10 to the 500th states, but 10 to the 123rd states to make the initial conditions probable, and no version of the multiverse that has been proposed contains anything close to this number of states. The physicist George Ellis at the University of Cape Town has argued that the multiverse hypothesis represents a departure from the scientific method that should not be accepted lightly. The multiverse is a philosophical hypothesis, not a scientific theory. It cannot be tested, it cannot be falsified, and the appeal to the multiverse to explain the fine-tuning is, in its logical structure, identical to the appeal to design. Both invoke an unobservable entity to explain an observed fact. Ellis's point is sharp. If the multiverse is accepted as a legitimate explanation despite being unobservable, then the design hypothesis must be accepted on the same terms, because both are unobservable entities invoked to explain the same observed fine-tuning. The debate between the multiverse and the design hypothesis reveals something important about the limits of the scientific method. Both hypotheses are invoked to explain the same observation, the fine-tuning. Both are unfalsifiable, neither can be directly tested. Both are inferred rather than observed. The multiverse is inferred from inflationary cosmology and string theory, and the designer is inferred from the improbability of the fine-tuning. And both carry metaphysical commitments that go beyond what the empirical data can establish. The multiverse commits to the existence of unobservable universes, and the design hypothesis commits to the existence of an unobservable intelligence. The philosopher Thomas Kuhn argued that scientific paradigm shifts occur not when the evidence compels the shift, but when the scientific community decides that one paradigm explains the evidence more satisfactorily than another. The fine-tuning debate is a paradigm-level debate, a confrontation between two comprehensive frameworks for understanding the nature of reality that the evidence alone cannot resolve. The resolution, if it comes, will come not from a single experiment, but from the progressive accumulation of theoretical insights, observational data, and philosophical arguments that tip the balance in the scientific community's judgment toward one framework or the other. The fourth answer is design. The design hypothesis says, the constants have their values because they were chosen, selected, set, determined by an intelligence that intended the universe to produce complex structures, consciousness, and observers. The fine-tuning is the fingerprint of a cosmic architect, the numerical signature of a purposive intelligence that designed the physical laws to produce the specific outcomes that the fine-tuning reveals. The design hypothesis is the oldest answer and the most intuitively natural. The impression of design that the fine-tuning produces is, as Paul Davies noted, overwhelming. The precision of the tuning, the specificity of the values, and the diversity of the independent parameters that are simultaneously tuned all point, with cumulative force, toward the conclusion that the tuning was performed deliberately, that the constants were chosen rather than accidental, that the universe was designed rather than random. The design argument has a long history in the Western intellectual tradition. William Paley's watchmaker analogy, 1802, the argument that the complexity of biological organisms implies a designer. Just as the complexity of a watch implies, a watchmaker was the most famous pre-Darwinian formulation. Darwin's theory of natural selection undermined Paley's argument at the biological level by providing a natural mechanism for the production of biological complexity. But the fine-tuning argument operates at a different level, the level of the physical constants that determine the laws of physics, not the level of the biological structures that the laws of physics produce. Natural selection cannot explain the fine-tuning, because natural selection operates within the laws of physics. It does not operate on the laws of physics. The fine-tuning is pre-biological. It concerns the numerical values that must be in place before any biology, any chemistry, and any structure can exist. The physicist and theologian John Polkinghorne, who was a professor of mathematical physics at Cambridge before being ordained as an Anglican priest, has argued that the fine-tuning provides the strongest modern form of the design argument, an argument that is immune to the Darwinian critique because it operates at the level of the physical laws rather than the biological structures. The fine-tuning is not biological, it is physical, and the physical fine-tuning requires an explanation that natural selection, operating within the physics, cannot provide. But the design hypothesis faces its own serious objections. The first objection is the identity of the designer. The design hypothesis says that an intelligence designed the universe, but it does not say who or what the intelligence is. Is the designer a god in the traditional sense, a personal, conscious, morally concerned creator? Is the designer an impersonal intelligence, a mathematical structure, a cosmic algorithm, a computational process that produces universes without awareness or intention? Or is the designer something else entirely, something that the human conceptual framework has no category for, and that the human language has no word for? The second objection is the regress problem. If the universe requires a designer because its fine-tuning is improbable, then the designer requires an explanation because the designer's existence is at least as improbable as the fine-tuning it explains. Who designed the designer? What fine-tuned the fine-tuner? The regress is infinite, each explanation requiring a further explanation, each designer requiring a further designer, unless the regress terminates in a necessary being, a being whose existence requires no explanation because the being's existence is necessary, self-caused, and self-sustaining. The third objection to the design hypothesis is the problem of evil. If the universe was designed by an intelligence, why does the design include suffering, death, natural disasters, and the second law of thermodynamics itself? The law that guarantees the dissolution of every structure and the death of every living thing. A designer who intended the universe to produce consciousness also designed a universe in which consciousness suffers. The problem of evil is not merely a theological challenge. It is a design challenge, a challenge to the hypothesis that the fine-tuning was performed by a benevolent intelligence that intended the well-being of the conscious creatures that the fine-tuning produces. The traditions provide various responses to the problem of evil. The Hindu concept of karma, suffering, is the consequence of past actions, serving the soul's development. The Buddhist concept of dukkha, suffering, is the nature of the conditioned, motivating the consciousness to seek the unconditioned. And the Christian concept of the felix culpa, the fortunate fall, the suffering that produces the greater good that only the experience of suffering can produce. Each response acknowledges the reality of the suffering while placing it in a larger context, a context in which the suffering serves a purpose that the suffering alone does not reveal. The physicist John Wheeler offered a scientific version of this response. The universe is a self-excited circuit that brings itself into existence through its own observations. If the universe is self-creating, if the fine-tuning is not the product of an external designer, but the self-organizing property of a self-referential, self-aware, self-sustaining cosmic process, then the suffering is not imposed from outside by a designer's choice. It is the inherent, structural, thermodynamically necessary consequence of the specific type of universe that the self-organizing process produces. A universe with entropy, with complexity, with consciousness, and with the impermanence that the second law guarantees. The philosopher Richard Swinburne has argued that the regress terminates in God, that the theistic God, defined as a necessary, eternal, self-existent being, is the only hypothesis that terminates the regress without producing a further explanatory demand. The physicist and theologian John Polkinghorne has argued similarly. The fine-tuning is evidence not of a designer within the universe, but of a ground of being that is the source of the universe, a ground that is not itself fine-tuned because it is not a contingent entity, but a necessary one. The contemplative traditions provide a specific response to the regress problem that the philosophical arguments cannot. The direct perception of the source. The traditions do not merely argue for the existence of the designer. They claim to perceive the designer directly, experientially, through the contemplative practices that we have examined throughout this series. The Hindu Jnana yogi perceives Brahman. The Buddhist meditator recognizes Rigpa. The Christian hesychast perceives the divine presence. And the perception, the traditions claim, terminates the regress not by argument, but by experience, by the direct awareness of a reality that is self-evident, self-luminous, and self-explaining, requiring no further explanation because it is its own ground, its own cause, and its own explanation. The physicist Freeman Dyson expressed the relationship between the four answers with characteristic balance. The more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. Dyson did not say the universe was designed. He said the universe knew. The language is careful. It acknowledges the impression of purpose, without committing to a specific mechanism, leaving open the possibility that the knowing is design, that the knowing is the multiverse's selection effect, that the knowing is the necessity of a deeper theory, or that the knowing is something that none of the four answers has yet adequately described. The physicist André Linde, one of the architects of eternal inflation, has described the fine-tuning debate with a candor that captures its current state. We have four possible explanations for the fine-tuning. The first three are scientifically respectable but philosophically unsatisfying. The fourth is philosophically satisfying but scientifically problematic. And the possibility that the correct answer is none of the four, that the true explanation transcends the categories that our current conceptual framework provides, is the possibility that should keep us humble." End quote. Linde's humility is appropriate. The fine-tuning is a fact. The explanations are hypotheses. And the gap between the fact and the hypotheses is the gap that the physics of the 21st century must bridge, either by discovering the necessity that makes the constants inevitable, by confirming the multiverse that makes them probable, by identifying the designer that makes them intentional, or by discovering a fifth explanation that none of the current categories contains. The question remains open. The chance hypothesis is improbable. The necessity hypothesis is undemonstrated. The multiverse hypothesis is unfalsifiable. And the design hypothesis is unverifiable. Each answer explains some features of the fine-tuning and fails to explain others. And the question of which answer is correct, or whether the correct answer transcends all four categories, is the question that the next stage of this investigation will pursue through the lens of the contemplative traditions, which have been investigating the cosmic architect, not through probability calculations, but through the direct perception of the intelligence that the fine-tuning implies. We have established that the fine-tuning of the fundamental constants produces an impression of design that the physics cannot resolve, that the four possible explanations, chance, necessity, multiverse, and design, each have specific strengths and specific weaknesses, and that the evidence alone does not compel any one of the four. The chance hypothesis is improbable. The necessity hypothesis is undemonstrated. The multiverse hypothesis is unfalsifiable. And the design hypothesis is unverifiable. But there is a fifth source of evidence that the physics debate has largely overlooked: the experiential testimony of the contemplative traditions. The traditions have been investigating the question of cosmic intelligence not through probability calculations and theoretical models, but through the direct, practice-dependent, experientially immediate perception of the intelligence that the fine-tuning implies, and their testimony accumulated over millennia across every culture through every contemplative method is unanimous. The intelligence is real. It is not an inference from the numbers. It is a perception as direct, as immediate, and as experientially vivid as the perception of light or sound. We will begin with Hinduism, which provides the most comprehensive philosophical framework for understanding cosmic intelligence. The Hindu tradition does not merely argue that the universe was designed by an intelligence. It describes the intelligence, its nature, its structure, its relationship to the created world, and the specific means by which the human consciousness can perceive it directly. The intelligence is Brahman, the infinite, formless, self-existent ground of all being that we have encountered throughout this series. But the fine-tuning investigation adds a specific dimension to the understanding of Brahman. Brahman is not merely the unchanging ground. Brahman is the intelligent ground, the ground that possesses the specific quality of intelligence, of knowing, of purposive ordering, that the fine-tuning reveals. The Rig Veda's hymn of creation, the Nasadiya Sukta, describes the moment before creation with a question that directly confronts the fine-tuning problem. Who really knows? Who can declare it? Whence was it produced? Whence this creation? The gods came afterwards, with the creation of this universe. Who then knows whence it has arisen? The hymn does not answer the question. It poses it, acknowledging that the origin of the cosmic order is a mystery that precedes the gods themselves, that the intelligence that designed the universe is more fundamental than any specific deity, and that the question of cosmic intelligence is the deepest question that the human mind can ask. The Upanishadic tradition provides the answer that the Rig Veda's question demands. The Taittiriya Upanishad describes the creation as the self-expression of Brahman. He desired, "May I become many, may I be born." He performed austerity. Having performed austerity, he created all this whatever exists. Having created it, he entered into it. The creation is not an external act, not a craftsman building a machine. It is a self-expression, the intelligence manifesting itself as the created world, entering into its own creation, and experiencing the creation from within. The fine-tuning is not the fingerprint of an external designer. It is the signature of a self-expressing intelligence, an intelligence that has manifested as the specific numerical values, the specific physical laws, and the specific cosmic structures that the fine-tuning reveals. The self-expression model of creation has a specific implication for the fine-tuning that the external designer model does not. The fine-tuning is not arbitrary. An external designer could, in principle, have chosen any values for the constants. The choice is free, the values are contingent, and the question of why these specific values were chosen rather than others remains open. But a self-expressing intelligence does not choose values arbitrarily. The values are determined by the intelligence's own nature, by the specific character, the specific qualities, and the specific creative tendencies of the intelligence that is expressing itself. The fine-tuning in the self-expression model is not a choice among possibilities. It is a necessity, the mathematically inevitable consequence of the specific intelligence that is doing the expressing. The Chandogya Upanishad's great declaration, Tat Tvamasi, thou art that, connects the fine-tuning directly to the perceiver. If the cosmic intelligence has expressed itself as the universe, and if you are part of the universe, then you are part of the intelligence's self-expression. The fine-tuning that produced the constants, that produced the chemistry, that produced the biology, that produced your consciousness, is the intelligence's way of expressing itself as you. You are not merely a product of the fine-tuning. You are the fine-tuning the intelligence's self-expression in the specific, conscious, self-aware form that the specific constants have made possible. The concept of Ishvara, the personal God, the creator aspect of Brahman, provides the specific framework for understanding the cosmic intelligence as an intelligent agent. Ishvara is Brahman perceived through the lens of creation. Brahman as the specific, purposive, creatively active intelligence that designs, produces, and sustains the physical world. The Bhagavad Gita describes Ishvara through Krishna's self-revelation to Arjuna. I am the source of all spiritual and material worlds. Everything emanates from me. Krishna is not claiming to be one God among many. Krishna is claiming to be the intelligence from which the world emanates, the cosmic architect whose specific, purposive, mathematically precise creative activity produces the specific world that the fine-tuning describes. The Samkhya philosophy adds a specific mechanism. Samkhya describes the creation as the interaction between Purusha, consciousness, the intelligent principle, and Prakriti, nature, the material principle. Purusha does not create Prakriti. Purusha illuminates Prakriti, and the illumination sets Prakriti into motion, causing it to differentiate from its original, undifferentiated state into the specific, structured, finely tuned configuration that the physical world displays. The illumination is the intelligence. The differentiation is the fine-tuning. And the specific structures that the differentiation produces, the specific forces, the specific constants, the specific chemistry, are the specific consequences of the specific illumination that Purusha provides. The Yoga Sutras of Patanjali add a specific practice-based dimension to the Samkhya framework. Patanjali's Sutra 1.24 defines Ishvara as a special Purusha, untouched by the afflictions, actions, results of actions, and latent impressions. Ishvara is the cosmic intelligence in its purest form, the Purusha that has never been entangled with Prakriti, that has never been obscured by the afflictions of ignorance, egoism, and attachment, and that perceives the created world with perfect clarity, perfect comprehension, and perfect intelligence. The fine-tuning is Ishvara's perception, the specific, precise, mathematically exact way in which the pure intelligence perceives and therefore constitutes the physical world. Patanjali's Sutra 1.25 adds, in Ishvara, the seed of omniscience has reached its highest development. The omniscience is the intelligence, the complete, unlimited, all-encompassing knowledge that includes the knowledge of every constant, every force, every relationship in the physical world. The fine-tuning is not imposed on the world by an external intelligence. It is the form that omniscience takes when it manifests as a physical world, the specific, numerical, mathematically precise form that the complete knowledge of the cosmic intelligence produces when it expresses itself as the structured reality that we inhabit. The Vedantic philosopher Ramanuja, who developed the Vishishtadvaita school of Hindu philosophy, described the relationship between the cosmic intelligence and the physical world with an image that directly addresses the fine-tuning. The universe is the body of God. The physical world, with its specific constants, its specific forces, its specific structures, is not separate from the cosmic intelligence. It is the intelligence's body, the specific, physical, numerically precise expression of the intelligence's nature. The fine-tuning is not the evidence of a designer who is separate from the design. It is the anatomy of the designer, the numerical structure of the cosmic intelligence's physical self-expression. The practice for perceiving the cosmic intelligence directly is bhakti yoga, the yoga of devotion, the cultivation of a loving, personal, emotionally engaged relationship with the divine intelligence. The bhakti yogi does not merely believe that the cosmic intelligence exists. The bhakti yogi loves the intelligence, and the love, sustained through practice, deepens into perception. The devotee who loves Krishna with sufficient intensity, the tradition teaches, eventually perceives Krishna directly, experientially, with the full force of personal encounter, and the perception is not of an abstract principle or a mathematical structure. It is of a person, an intelligent, aware, loving, creatively active person who is the source of the specific world that the fine-tuning reveals. The perception of the cosmic intelligence through bhakti is not a hallucination. It is not wish fulfillment. It is not the projection of human desire onto an impersonal universe. It is a specific, reproducible, practice-dependent perceptual shift in which the devotee's consciousness, focused with sufficient intensity and sustained with sufficient duration on the divine object, achieves a resonance with the cosmic intelligence that produces a direct, unmediated, experientially immediate awareness of the intelligence's presence, nature, and character. The Bhakti Sutras of Narada describe the stages of this perception. First, the intellectual conviction that the intelligence exists, based on the evidence, the arguments, and the testimony of the tradition. Second, the emotional engagement with the intelligence, the cultivation of love, devotion, and longing for the divine. Third, the experiential encounter, the direct perception of the intelligence's presence in the devotee's consciousness. And fourth, the permanent transformation, the sustained awareness of the intelligence's presence in every moment, every experience, and every aspect of the devotee's life. The stages describe a progression from inference to experience, from the intellectual assessment of the fine-tuning evidence to the direct perception of the intelligence that the fine-tuning implies. The contemporary Hindu teacher Swami Sarvapriyananda has described the perception of Brahman in terms that bridge the scientific and the contemplative. The fine-tuning evidence is like a letter written in an unfamiliar language. You can see that the letter is written, you can see the structure, the order, the intentionality, but you cannot read it. The contemplative practice is the learning of the language, the development of the perceptual capacity that allows you to read the letter, to understand the intelligence that wrote it, and to recognize, in the specific numerical values of the constants, the specific message that the intelligence is communicating. In Buddhism, the question of cosmic intelligence takes a radically different philosophical form, but the experiential outcome converges with the Hindu testimony in ways that are significant for the fine-tuning debate. The Buddhist tradition, in its classical formulation, does not posit a creator God. The universe, in the Buddhist cosmology, is not created by an external intelligence. It arises through dependent origination, through the mutual conditioning of phenomena by other phenomena, in a web of causation that has no first cause, no ultimate origin, and no intelligent designer standing outside the web and directing its activity. But the Buddhist tradition does recognize an intelligence that pervades the universe, an intelligence that is not external to the universe, but intrinsic to it. The Huayan Buddhist concept of the Dharmadhatu, the realm of reality in which all phenomena interpenetrate without obstruction, describes a universe that is not random but ordered, not chaotic but structured, not arbitrary, but governed by specific principles that produce specific, predictable, reliable outcomes. The Dharmadhatu is an intelligent structure, a structure in which the relationships between phenomena are not accidental but lawful, in which the specific configurations that arise are not arbitrary but determined by the specific conditions that produce them, and in which the overall pattern of the structure displays the specific, precise, mathematically describable order that the fine-tuning reveals. The Buddhist teacher Thich Nhat Hanh described the Dharmadhatu's intelligence with an image that connects it to the fine-tuning. When you look at an orange, you can see the entire cosmos in it, the sun that warmed it, the rain that nourished it, the earth that supported it, the farmer who tended it. The orange is the cosmos, made visible in a specific form, and the cosmos is intelligent not because it planned the orange, but because the relationships between its elements are so precisely ordered that an orange can arise from them. The intelligence is in the relationships, in the specific numerical values of the forces, the constants, and the conditions that produce, from the undifferentiated quantum fields, the specific, structured, astonishingly complex world that the fine-tuning permits. The Prajnaparamita literature, the perfection of wisdom texts that constitute the philosophical foundation of Mahayana Buddhism, describes the intelligence as prajna, wisdom, the direct, non-conceptual, experientially immediate perception of the way things are. Prajna is not theoretical knowledge about the fine-tuning. It is the direct perception of the intelligence that the fine-tuning expresses the immediate, non-mediated awareness of the ordered, structured, precisely calibrated reality that the constants produce. The practitioner who develops prajna does not learn about the cosmic intelligence. The practitioner perceives it directly through the contemplative practice that the Prajnaparamita literature describes, and with a certainty that no theoretical argument can match. The Buddhist concept of the Dharmakaya, the truth body of the Buddha, the ultimate dimension of reality that transcends the specific forms of the manifest world, describes the intelligence at its deepest level. The Dharmakaya is not a person. It is not a creator. It is the intelligence itself, the knowing, the awareness, the luminous cognizance that pervades every point of the Dharma Dhatu and that constitutes the fundamental quality of reality. The Dharmakaya is not separate from the phenomena it pervades. It is the phenomena*s deepest nature, the intelligence that the phenomena express, the knowing that the structures display, and the awareness that the fine-tuning reveals at the level of the physical constants. The Yogacara Buddhist concept of vinapti matra, consciousness only, the doctrine that reality is fundamentally mental rather than material, provides the most radical Buddhist framework for understanding the fine-tuning. If reality is consciousness only, then the physical constants are not properties of an external, mind-independent physical world. They are properties of the consciousness that constitutes reality, properties of the mind that manifests as the physical world, properties of the intelligence that expresses itself as the specific numerical values that the fine-tuning reveals. The fine-tuning is not the evidence of an external intelligence designing a physical world. It is the structure of the intelligence itself, the specific, mathematical, numerically precise form that the universal consciousness takes when it manifests as the physical world. The Yogacara framework has a specific implication for the fine-tuning debate. If reality is consciousness only, then the fine-tuning is not a property of a physical world that consciousness observes. It is a property of the consciousness itself, a structural feature of the universal mind that produces the specific, mathematically precise, finely tuned reality that the observation reveals. The question, who fine-tuned the constants, becomes, in the Yogacara framework, why does consciousness have this specific structure? And the answer, according to the Yogacara, is that the structure is determined by the accumulated karma, by the totality of all actions, intentions, and mental states that have ever occurred in the consciousness stream and that have produced, through their cumulative effect, the specific configuration of the universal consciousness that manifests as the specific physical world with the specific constants that the fine-tuning reveals. The Buddhist philosopher Vasubandhu formalized this in his 20 verses. All this is consciousness only. The external world is a manifestation of the seeds stored in the storehouse consciousness. The seeds, the bija, are the karmic impressions that the consciousness has accumulated over countless lifetimes. The physical world, including its specific constants, is the manifestation of the seeds, and the fine-tuning is the specific pattern of the seeds, the specific configuration of the accumulated karma that produces the specific world that the consciousness inhabits. The Madhyamaka philosopher Chandrakirti adds a crucial nuance. The fine-tuning is neither designed nor undesigned. It is empty of inherent existence, empty of the fixed, permanent, independently existing nature that either the design hypothesis or the chance hypothesis attributes to it. The constants are what they are because of conditions, but the conditions are not external to the consciousness that perceives them. The conditions are the consciousness, and the consciousness is the conditions. The fine-tuning is the mutual conditioning of consciousness and world, of perceiver and perceived, in the web of dependent origination that constitutes the Dharmadhatu. The Zen tradition confronts the question of cosmic intelligence with its characteristic directness. The koan, "Does a dog have Buddha nature?" is not asking about dogs. It is asking about the pervasiveness of the intelligence, whether the Buddha nature, the awakened awareness, the cosmic intelligence pervades not only conscious beings but every element of the physical world, including the specific numerical values of the fundamental constants. The Zen master Zhao Zhao's answer, mu, no or nothing, is not a denial. It is a transcendence, a refusal to answer the question within the dualistic framework that the question presupposes, and a pointing toward the direct perception of the intelligence that transcends the categories of yes and no, of design and accident, of intelligence and non-intelligence. The Zen master Dogen resolved the koan with his characteristic depth. All beings are Buddha nature, not that all beings have Buddha nature as a property they possess. All beings are Buddha nature. They are the cosmic intelligence, expressing itself in every form, every constant, every numerical value that the physical world displays. The stone is Buddha nature. The electron is Buddha nature. The fine structure constant is Buddha nature. And the fine-tuning is not the evidence of a designer separate from the design. It is the design being the designer, the intelligence expressing itself as the specific numerical values that constitute the physical world. The neuroscience of meditation provides empirical support for the contemplative tradition's claim that the cosmic intelligence is perceivable. The neuroscientist Andrew Newberg's brain imaging studies of meditators and contemplatives from multiple traditions show that deep contemplative practice produces specific, measurable changes in brain function that are consistent with the perception of an intelligence that pervades reality. The decreased activity in the parietal lobe, the region that maintains the sense of spatial and temporal boundaries, produces the experience of boundlessness, of unity, of the dissolution of the separation between the perceiver and the perceived. The increased activity in the prefrontal cortex produces the experience of heightened awareness, of focused attention, of the clarity that the traditions describe as the perception of the intelligence's presence. Newberg does not claim that these brain changes prove the existence of a cosmic intelligence. He claims that they demonstrate that the brain is capable of producing the perceptual states that the traditions describe, that the perception of cosmic intelligence is not a fantasy or a delusion, but a specific, reproducible, neurologically real perceptual state that specific practices reliably produce. The perception may reflect a genuine intelligence, or it may reflect the brain's internal processing. But the perception itself is real, and the consistency of the perception across traditions, across cultures, and across centuries constitutes a body of experiential evidence that the fine-tuning debate should not ignore. In Christianity, the concept of cosmic intelligence is expressed through the Logos, the divine word, the rational principle, the creative intelligence that the Gospel of John identifies as the agent of creation. The Logos is not merely a force or a principle, it is a person, the second person of the Trinity, the Divine Son, the eternal Word through whom all things were made. The Christian tradition's concept of cosmic intelligence is therefore personal. The intelligence that designed the universe is not an impersonal mathematical structure or a blind computational process, but a conscious, purposive, loving intelligence that created the world through a deliberate act of will, and that sustains the world through continuous creative engagement. The theologian Thomas Aquinas formalized the argument from design in his fifth way, the argument from the governance of things. Aquinas observed that natural things act for an end, that the regularity, the predictability, and the goal-directedness of natural processes imply the existence of an intelligence that directs them toward their ends. The fine-tuning is the modern, quantitative, experimentally precise version of Aquinas' fifth way. The specific numerical values of the constants are the specific ends toward which the natural processes are directed, and the specific, precise, extraordinarily narrow ranges within which the values fall imply the existence of the intelligence that directed them there. The concept of divine wisdom Sophia provides the specific quality of the cosmic intelligence that the fine-tuning reveals. The book of Proverbs describes wisdom as present at the creation. The Lord brought me forth as the first of his works, before his deeds of old. I was formed long ages ago, at the very beginning, when the world came to be. When he established the heavens, I was there. Proverbs 8:22-7. The wisdom is not merely intelligence in the computational sense, the ability to process information and produce outputs. It is wisdom in the qualitative sense, the ability to produce beauty, to produce harmony, to produce the specific, elegant, mathematically beautiful order that the physicist Dirac identified as the hallmark of the fundamental laws. The fine-tuning is not merely precise, it is beautiful, and the beauty is the signature of wisdom rather than mere intelligence. The physicist and theologian John Polkinghorne has argued that the beauty of the fundamental laws is itself a form of evidence not of a designer who calculated the optimal constants, but of a wisdom that expressed itself in the specific form of beauty that the constants display. The world is not just rationally transparent, Polkinghorne writes, it is also rationally beautiful, and the beauty suggests not an engineer, but an artist, not a calculator, but a creator, whose nature is expressed in the aesthetic quality of the creation. The Cappadocian Father Basil of Caesarea described the cosmic intelligence with an image that connects the fine-tuning to the creative act. The world is a work of art, displayed for the beholding of all people, so that through it the wisdom of him who created it may be known. The world is art. The fine-tuning is the technique, the specific, precise, mathematically describable technique by which the artist produced the specific work that the world displays. And the perception of the technique, the recognition of the fine-tuning's precision, specificity, and improbability is the perception of the artist's wisdom. The theologian Maximus the Confessor developed the concept of the logoi, the specific, divine, rationally ordered principles that govern every created thing, into a comprehensive framework for understanding the fine-tuning. Each fundamental constant has its own logos, its own specific, divinely ordained, rationally structured value that the logos has established for the specific purpose of producing the specific cosmic outcome that the constant contributes to. The fine-tuning is the collective expression of the logoi, the total set of divinely ordained values that the logos has inscribed in the structure of the physical world and that the physics measures with its instruments. The Orthodox theologian Dumitru Staniloae developed Maximus's framework into what he called the cosmic liturgy, the understanding that the fine-tuning is not merely evidence of design, but an act of worship. The constants do not merely permit the existence of complex structures, they celebrate the existence of complex structures expressing, through their specific values, the divine joy in creation that the theology identifies as the motive for the creative act. The fine-tuning is not the product of cold calculation, it is the product of creative joy. The cosmic intelligence's delight in producing a world that is not merely functional but beautiful, not merely ordered but glorious. The Jewish tradition adds a specific dimension through the concept of chokhmah, wisdom, the divine attribute through which the world was created. The book of Job describes the divine wisdom's role in the cosmic order. Where were you when I laid the earth's foundation? Tell me, if you understand. Who marked off its dimensions? Surely you know. Job 38 4-5. The passage is a divine challenge, a reminder that the specific dimensions, the specific values, the specific fine-tuning were established by a wisdom that the human intellect can recognize but cannot fully comprehend. The recognition of the fine-tuning is the beginning of wisdom. The comprehension of the fine-tuning is beyond wisdom, because the intelligence that produced the tuning transcends the intelligence that recognizes it. The mystic and scientist Teilhard de Chardin described the cosmic intelligence not as an external designer but as an immanent presence, an intelligence that is within the creation, that is expressed by the creation, and that is evolving through the creation toward a state of maximum self-awareness. Teilhard's cosmic intelligence is not the watchmaker of Paley's analogy, an external craftsman who builds a machine and then stands back to watch it run. It is the machine itself, the universe, as a self-organizing, self-aware, self-evolving intelligence that has fine-tuned its own constants through the evolutionary process that the intelligence itself constitutes. The convergence between the traditions on the nature of cosmic intelligence can now be stated with precision. Hinduism says, the cosmic intelligence is Brahman-Ishvara, the self-expressing, self-entering, self-experiencing ground of being that manifests as the specific physical world through its own creative activity. Buddhism says, the cosmic intelligence is the Dharmakaya, the luminous cognizance that pervades the Dharmadhatu and that constitutes the deepest nature of every phenomenon, including the fundamental constants. Christianity says, the cosmic intelligence is the Logos, the personal, purposive, creative word that designed the universe with the specific numerical precision that the fine-tuning reveals. The Taoist tradition describes the cosmic intelligence through the concept of the Tao's spontaneous creativity, Wu Wei, the effortless, unforced, naturally arising activity that produces the 10,000 things without intention, without design, and without the deliberate, conscious planning that the Western design argument assumes. The Tao does not design the universe the way an architect designs a building. The Tao produces the universe the way a spring produces water naturally, spontaneously, effortlessly, without a plan and without a purpose, yet producing, through the natural expression of its own nature, the specific, ordered, finely tuned world that the physics describes. The Taoist perspective is neither design nor accident. It is a third category, spontaneous order, natural intelligence, the effortless expression of an intelligence that is not separate from the world it produces, and that does not precede the world it produces, but that is the world's own deepest nature, manifesting spontaneously as the specific constants, the specific forces, and the specific structures that the fine-tuning reveals. The traditions disagree on whether the intelligence is personal. Hinduism and Christianity say yes, at least in some of its aspects. Classical Buddhism says no, and on whether the intelligence is separate from the universe, Christianity says yes. In the sense that the creator transcends the creation, Hinduism and Buddhism say no, in the sense that the intelligence is identical to the reality it produces. But the traditions agree on the core claim. The universe is not an accident, the fine-tuning is not a coincidence, and the specific, precise, mathematically describable order that the physical constants display is the expression of an intelligence that is real, that is perceivable, and that the contemplative practices can access directly. The direct perception of the cosmic intelligence is the tradition's contribution to the fine-tuning debate that the physics cannot provide. The physics can measure the fine-tuning. The physics can calculate the probabilities. The physics can evaluate the four explanations. But the physics cannot perceive the intelligence, cannot experience, from within, the knowing that the fine-tuning implies. The traditions can, and their perception, reported across every culture, every century, and every contemplative method, is that the intelligence is real, that it is accessible, and that the perception of it transforms the perceiver's understanding of the fine-tuning from an abstract numerical puzzle into a direct encounter with the cosmic mind. The physicist Wolfgang Pauli, who collaborated with Carl Jung on the relationship between physics and the psyche, described the fine-tuning debate in terms that honor both the physics and the traditions. The problem of the fine-tuning is not a physics problem, it is a human problem. A problem of the relationship between the human consciousness and the cosmic order in which the consciousness is embedded. The physics can measure the order, the traditions can perceive the intelligence behind the order, and the integration of the two, the measurement and the perception, the number and the experience, the equation and the awareness, is the task that the 21st century must accomplish. Pauli's task remains unaccomplished. The physics and the traditions have not been integrated. The measurement and the perception remain in separate domains. The physicist measuring the constants in the laboratory, the contemplative perceiving the intelligence in the meditation hall, and the two rarely meeting. But the convergence that this investigation has documented, the convergence between the fine-tuning evidence and the contemplative testimony, between the improbability of the constants and the ubiquity of the perception, between the numbers that should not work and the intelligence that the traditions say made them work, is the beginning of the integration that Pauli envisioned. In the final stage, we will bring everything together, the fine-tuning evidence, the four explanations, and the contemplative tradition's experiential testimony, and ask what the great architect paradox reveals about you, about a being who exists because the constants are fine-tuned, who is conscious because the fine-tuning permits consciousness, and who is capable, through the contemplative practices that the traditions provide, of perceiving the intelligence that the fine-tuning implies, not as a number, not as a probability, not as a theoretical inference, but as a direct, experiential encounter with the cosmic mind from which the specific universe that you inhabit has been projected. We have now assembled every piece of the argument. The physics has established that the fundamental constants of nature are fine-tuned to a precision that ranges from 14% for the strong force to 120 decimal places for the cosmological constant, a precision so extreme that the probability of the observed values arising by chance is by any reasonable calculation indistinguishable from zero. The four explanations, chance, necessity, multiverse, and design, each account for some features of the fine-tuning and fail to account for others, and the question of which explanation is correct remains one of the deepest unsolved problems in physics, and the contemplative traditions have provided a fifth source of evidence, the direct, experiential, practice-dependent perception of a cosmic intelligence that the fine-tuning implies, and that the traditions describe, with varying degrees of philosophical precision, as Brahman, the Dharmakaya, the Logos, and the Tao. Now we must bring everything together and ask what the great architect paradox reveals about reality, about consciousness, about the relationship between the intelligence that designed the constants and the intelligence that perceives them, and about you. Let us begin with the paradox itself. The great architect paradox is this: the universe appears to have been designed by an intelligence, but the identity, nature, and location of the intelligence cannot be determined by the methods that detected the design. The physics can measure the fine-tuning with extraordinary precision. The physics can calculate the probabilities with rigorous mathematics. And the physics can establish, beyond reasonable doubt, that the specific values of the constants fall within ranges that are extraordinarily narrow, extraordinarily improbable, and extraordinarily specific in the outcomes they produce. But the physics cannot determine who or what established the values, cannot identify the architect, cannot locate the architect, and cannot determine whether the architect is a conscious being, an unconscious process, a mathematical necessity, or something that the current conceptual framework has no category for. The paradox is not a failure of the physics. It is a consequence of the nature of the question. The question of why the constants have the values they have is not a question that can be answered from within the universe that the constants govern. The constants define the rules of the game. Asking why the rules are these specific rules is asking a question from outside the game, a question that the game's internal logic cannot address, because the game's internal logic presupposes the rules rather than explaining them. The philosopher Ludwig Wittgenstein described this limitation with his characteristic precision. The facts of the world are not the end of the matter. The existence of the world itself is the miracle. The fine-tuning is not a fact within the world. It is a fact about the world, a fact about the conditions that make the world possible, the parameters that define the world's structure, and the specific values that produce the specific world that the specific consciousness inhabits. The fine-tuning is the miracle that Wittgenstein described, the miracle of the world's existence, expressed in the specific numerical values that the existence requires. The physicist Eugene Wigner described the same limitation from the scientific perspective. The unreasonable effectiveness of mathematics in the natural sciences is something bordering on the mysterious, and there is no rational explanation for it. The fine-tuning is the specific expression of Wigner's mystery. The mathematical structure of the physical world is not merely effective but extraordinarily, improbably, precisely effective, producing, from the specific values of the constants, the specific universe that the specific consciousness inhabits. The effectiveness is unreasonable because it cannot be explained from within the mathematical framework that the effectiveness displays. The explanation, if it exists, lies outside the framework in the domain that the physics calls metaphysics and that the contemplative traditions call the source. The great architect paradox is not a new problem. It is the oldest problem in the history of human thought, the problem of the ground, the question of what supports the foundation, the inquiry into the ultimate why that every chain of explanation eventually reaches. Aristotle called it the first cause. Leibniz called it the principle of sufficient reason. And the modern physics has given it a specific, quantitative, experimentally measurable form. Why do the constants have these values? The question is ancient. The precision of the question is new. And the precision makes the question more urgent, not less, because the precision reveals the extraordinarily narrow range within which the values must fall, and the extraordinarily improbable coincidence that they do. The philosopher Martin Heidegger described the question as the fundamental question of metaphysics. Why are there beings at all instead of nothing? The fine-tuning transforms Heidegger's question from a philosophical abstraction into a physical measurement. The constants could have had values that produce nothing: no stars, no atoms, no chemistry, no structure, no observers. The constants could have had values that produce something but not this specific. Something universes with structure, but not with the specific structure that produces, the specific chemistry that produces, the specific biology that produces consciousness. The fact that the constants have the specific values that produce this specific universe, a universe with consciousness, is the physical, measurable, experimentally confirmed expression of Heidegger's wonder that there is something rather than nothing. Now let us consider what the fine-tuning reveals about consciousness. The most striking feature of the fine-tuning is that it is tuned for consciousness, not merely for structure, not merely for atoms, molecules, stars, and planets. The fine-tuning is specific enough to produce chemistry, specific enough to produce biology, specific enough to produce neural systems, and specific enough to produce the specific form of consciousness that can perceive the fine-tuning and ask why the constants have the values they have. The fine-tuning does not merely permit consciousness. It appears to be aimed at consciousness calibrated with extraordinary precision to produce the specific conditions that the specific consciousness requires. The physicist John Wheeler described this with his concept of the participatory universe. The universe is not merely observed by conscious beings. The universe is brought into existence by conscious beings through the quantum mechanical act of observation that selects specific outcomes from the superposition of possible outcomes, and that thereby constitutes the specific, definite, classical reality that the observation produces. The consciousness is not a passive spectator of the fine-tuning. The consciousness is a participant, an essential, constitutive, actively involved participant in the production of the specific reality that the fine-tuning permits. Wheeler's participatory universe implies a specific relationship between the fine-tuning and the consciousness. The consciousness does not merely arise from the fine-tuning. The consciousness participates in the fine-tuning, contributing, through its observations, to the specific quantum outcomes that constitute the specific classical reality that the fine-tuning describes. The relationship is circular. The fine-tuning produces the consciousness, and the consciousness produces the reality that the fine-tuning describes. The circle is Wheeler's self-excited circuit, the self-referential, self-sustaining, self-creating process in which the universe brings itself into existence through its own observation. The Wheeler circuit dissolves the great architect paradox in a specific way. The paradox asks, who designed the universe? The circuit answers, the universe designed itself through the self-referential process in which the consciousness that the fine-tuning produces participates in the reality that the fine-tuning describes. The architect is not external to the architecture. The architect is the architecture, the self-organizing, self-aware, self-creating intelligence that constitutes both the designer and the design, both the observer and the observed, both the consciousness that perceives the fine-tuning and the fine-tuning that produces the consciousness. The Wheeler circuit has a specific implication for the fine-tuning. The constants may not have been set before the universe began. They may have been established retroactively through the quantum mechanical process of delayed choice that Wheeler himself described, in which the observation performed in the present determines the properties of the system in the past. The consciousness that the fine-tuning produced may have retroactively established the fine-tuning that produced it through the temporal feedback loop that the block universe permits, and that the retrocausal experiments of Aharonov and others have demonstrated at the quantum level. The physicist Paul Davies has explored this possibility in detail, arguing that the fine-tuning may be the product of a self-consistency loop, a loop in which the universe's physical laws produce conscious observers, and the conscious observers, through their quantum mechanical observations, select the specific physical laws that produce them. The loop is not paradoxical because it does not require backward causation in the linear, temporal sense. It requires the self-consistency of the block universe, the requirement that the block's four-dimensional structure be internally consistent, with the observers at one temporal location being compatible with the physical laws at every temporal location. The physicist André Linde has proposed a related idea, the participatory cosmology, in which the universe's evolution is not determined solely by the initial conditions and the physical laws, but is co-determined by the observations that the conscious beings within the universe perform. The conscious observers do not merely arise from the fine-tuning. They participate in the fine-tuning, contributing, through their observations, to the specific quantum outcomes that constitute the specific classical reality that the fine-tuning describes. The contemplative traditions describe this self-referential relationship with their own language. The Hindu tradition describes it as Brahman expressing itself as the world and then perceiving itself through the world's conscious beings. The Buddhist tradition describes it as the Dharmakaya, manifesting as the phenomenal world and then recognizing itself through the awakened awareness of the Buddha. The Christian tradition describes it as the Logos, creating the world through divine speech and then hearing itself through the world's response. Each tradition describes the same circular, self-referential, self-creating process that Wheeler's circuit formalizes in physical terms. The physicist Roger Penrose has described the self-referential structure in mathematical terms through his concept of the three worlds: the physical world, the world of matter, energy, and forces; the mental world, the world of consciousness, perception, and experience; and the mathematical world, the world of abstract structures, logical truths, and mathematical relationships. Each world gives rise to the next. The mathematical world gives rise to the physical world through the mathematical structure of the physical laws. The physical world gives rise to the mental world through the neural processes that produce consciousness, and the mental world gives rise to the mathematical world through the mathematical intuition that perceives the mathematical structures. The three worlds form a loop, each one producing the next, each one dependent on the previous, and the entire structure self-referential, self-sustaining, and self-explaining. Penrose's three-world loop is the fine-tuning's deepest structure. The mathematical world, the unchanging mathematical structure that the constants express, produces the physical world, the specific physical reality that the specific constants determine. The physical world produces the mental world, the specific consciousness that the specific physics permits. And the mental world perceives the mathematical world, recognizing, in the specific values of the constants, the specific mathematical structure that the consciousness's own existence requires. The loop is the architect, the self-referential, self-creating, self-perceiving process that produces the universe, that produces the consciousness, and that produces the recognition of the fine-tuning that makes both possible. The contemplative tradition's contribution to the three-world loop is the claim that the loop can be perceived directly, that the consciousness, through the specific practices of the traditions, can perceive not merely the mathematical world through physics or the physical world through the senses, but the loop itself, the self-referential structure in which the three worlds arise, from each other, sustain each other, and constitute, together, the single, unified, self-aware reality that the word universe inadequately names. Now let us connect the great architect paradox to every investigation in this series. In our investigation of time, we established that the block universe contains all moments simultaneously. The fine-tuning is the block's blueprint, the specific set of numerical values that determines the block's structure, the block's content, and the specific trajectory of the temporal process that the block contains. The block is not designed within time. The block is designed outside of time by the intelligence, the necessity, or the self-organizing process that establishes the specific values from which the entire four-dimensional structure is determined. In our investigation of death, we establish that the information constituting a person is conserved. The fine-tuning is the conservation's foundation, the specific numerical values that produce the specific physical laws that guarantee the conservation. If the constants were different, the conservation laws might be different. The specific conservation of information depends on the specific unitarity of quantum mechanics, which depends on the specific mathematical structure of quantum mechanics, which depends on the specific values of the constants. The fine-tuning preserves your information by establishing the specific physics that makes information preservation an absolute, unconditional, inviolable law. In our investigation of the hidden layer, we establish that the visible world is a surface concealing a deeper reality. The fine-tuning is the hidden layer's specification, the numerical code that the hidden layer uses to produce the specific, visible surface that the consciousness perceives. The holographic boundary encodes information. The fine-tuning determines what information the boundary encodes, which constants, which forces, which particles, and which specific physics the boundary's information produces when projected into the three-dimensional bulk. In our investigation of the cosmic neural network, we establish that the universe may be a mind. The fine-tuning is the mind's architecture, the specific numerical values that produce the specific neural structure of the cosmic mind, determining the strength of the connections, the speed of the signals, and the specific processing capacity that the cosmic mind's network displays. In our investigation of evolution, we establish that evolution may be a quantum algorithm computing toward consciousness. The fine-tuning is the algorithm's code, the specific numerical instructions that the algorithm executes, determining which chemical reactions are possible, which molecular structures are stable, and which evolutionary trajectories can produce the specific biological complexity that consciousness requires. In our investigation of the inseparable quark, we establish that isolation is forbidden. The fine-tuning is the non-isolation's mechanism, the specific value of the strong force coupling constant that prevents the quarks from separating and that establishes, at the deepest level of matter, the connectedness that every subsequent investigation has confirmed at every scale. In our investigation of the unchanging source, we establish that something persists while everything else decays. The fine-tuning is the persisting, the specific numerical values that constitute the unchanging structure of the physical world, that do not change when the structures they produce change, and that persist, unaltered, through every anthropic dissolution that the second law prescribes. In our investigation of vibration, we establish that the universe is made of vibrations in quantum fields. The fine-tuning determines the specific vibrational frequencies, the specific energy levels, the specific resonances, and the specific harmonics that the quantum fields support. The Hoyle carbon resonance is the most dramatic example. The specific vibrational frequency of the carbon 1,2 nucleus, tuned to within 4% of the frequency that permits carbon production, is the fine-tuning expressed as a specific vibration. The universe is a symphony, and the fine-tuning is the tuning of the instruments that the symphony requires. In our investigation of information leakage, we establish that dreams may contain fragments of other realities. The fine-tuning determines which realities are possible, which sets of constants produce viable universes, which branches of the wave function contain complex structures, and which configurations of the multiverse produce the specific conscious beings that the dreams are leaking between. The fine-tuning is the selection criterion that determines the viable branches, the filter that separates the life-compatible configurations from the incomprehensibly vast space of life-incompatible configurations. In our investigation of the quantum Zeno effect, we establish that continuous observation sustains quantum states. The fine-tuning may be sustained by observation by the continuous, consciousness-mediated, quantum mechanical observation that Wheeler's participatory universe requires, and that the Zeno effect demonstrates at the laboratory scale. The constants may not be fixed once and for all at the Big Bang. They may be continuously sustained by the observations that the conscious beings perform maintained through the Zeno effect, at the specific values that the consciousness requires for its own existence. Every investigation in this series has been an investigation of the fine-tuning's consequences, an examination, from a different angle, of the specific world that the specific constants produce. The time investigation examined the fine-tuning's temporal consequences. The distance investigation examined its spatial consequences. The evolution investigation examined its biological consequences. The consciousness investigation examined its cognitive consequences, and this investigation has examined the fine-tuning itself, the numerical foundation on which every subsequent consequence is built. Now we must state the objections. The first objection is that the fine-tuning may not be as extreme as the proponents claim. The physicist Victor Stenger argued that many of the constants can be varied over wider ranges than the fine-tuning literature suggests, and still produce universes capable of some form of complexity. The astronomer Fred Adams has shown that stars can exist over a much wider range of constant values than Martin Rees's analysis assumed, that the nuclear physics of stellar energy production is more robust than the simple estimates suggest. These arguments do not eliminate the fine-tuning, but they reduce its severity, suggesting that the life-permitting region of parameter space may be larger than the most extreme fine-tuning claims imply. Adams's analysis is important but limited. Adams showed that stars objects that sustain nuclear fusion can exist over a wider range of constants than previously assumed, but he did not show that the specific chemistry, the specific biology, and the specific consciousness that the observed universe contains can exist over a wider range. The existence of stars is necessary for life, but not sufficient. Life requires not merely stars, but the specific elements that the specific stars produce, the specific chemistry that the specific elements support, and the specific biological complexity that the specific chemistry permits. The fine-tuning at the stellar level may be less extreme than the proponents claim, but the fine-tuning at the chemical, biological, and cognitive levels may be more extreme because each level adds additional constraints that the stellar level alone does not capture. The physicist Max Tegmark has responded to the Stenger-Adams objection by distinguishing between strong fine-tuning, the claim that the life-permitting range is extremely narrow and weak; fine-tuning, the claim that the life-permitting range is narrower than would be expected by chance. Tegmark argues that even if strong fine-tuning is overstated for some constants, weak fine-tuning is robustly established for all of them. The life-permitting range is always a small fraction of the total range, and the combined probability of all the constants simultaneously falling within their respective life-permitting ranges remains extraordinarily small. The second objection is that the fine-tuning argument assumes that the constants are independent, that each constant could be varied independently of the others, but the constants may be correlated, connected by deeper relationships that the current physics has not yet discovered. If the constants are correlated, then the probability of the observed values is not the product of the individual probabilities, but a potentially much larger number that the correlation determines. The fine-tuning may be an artifact of our ignorance of the correlations rather than a genuine feature of the parameter space. The third objection is that the impression of design is a cognitive bias, that the human mind evolved to detect patterns and to infer agency from order, perceives design where none exists. The psychologist Justin Barrett has demonstrated that human beings have a hyperactivity of agency detection, a cognitive tendency to attribute intelligent agency to natural phenomena, even when the phenomena are fully explicable by natural processes. The fine-tuning's impression of design may be a product of this cognitive bias rather than a genuine feature of the physical world. The fourth objection is the survivorship bias. We are here to observe the fine-tuning because the fine-tuning produced us. We cannot observe universes with different constants because we could not exist in those universes. The observation is biased by the survival of the observer, and the bias may produce the impression of design where only selection is at work. The survivorship bias objection is valid but insufficient. It explains why we observe life-compatible constants we could not observe anything else, but it does not explain why the life-compatible range is so extraordinarily narrow, why the precision of the tuning is so extreme, and why the specific values produce not merely life but the specific, extraordinary, improbably complex form of life that includes conscious beings capable of perceiving the fine-tuning and debating its significance. The survivorship bias explains the observation. It does not explain the phenomenon that is observed. The philosopher of science Elliot Sober has formalized this point. The selection effect explains why we observe fine-tuned constants. It does not explain why the constants are fine-tuned. The explanation of the observation selection and the explanation of the phenomenon, fine-tuning, are different explanations, answering different questions. And the question of why the constants are fine-tuned, the question of the phenomenon rather than the observation, remains open regardless of the selection effect. These objections are serious and must be acknowledged. The fine-tuning debate is not resolved. The evidence is suggestive but not conclusive. And the question of whether the constants were designed, necessary, accidentally realized in a multiverse, or produced by a mechanism that none of the four explanations captures, remains one of the deepest open questions in the history of human thought. So what does this mean for you? It means that your existence is not generic. You are not a random configuration of matter that could have arisen in any universe with any set of constants. You are a specific configuration, a configuration that depends on the specific value of the strong force coupling constant, which permits the nuclear physics that powers the stars that forge the elements that constitute your body, on the specific value of the fine structure constant, which permits the chemistry that produces the molecules that carry the information that encodes your consciousness, on the specific value of the cosmological constant, which permits the galaxies and the stars and the planets that provide the environment that your biology requires, and on the specific value of every other fine-tuned parameter that the physics has identified. You are the fine-tuning's consequence. Every atom in your body was produced by a star whose existence depends on the specific value of a fundamental constant. Every molecule in your cells is held together by electromagnetic forces, whose strength depends on the specific value of the fine structure constant. Every chemical reaction in your metabolism is driven by energy, whose availability depends on the specific value of the cosmological constant. And the consciousness with which you are reading these words is the product of a biological process whose existence depends on the simultaneous fine-tuning of dozens of independent parameters, each one calibrated to the specific value that produces the specific chemistry, the specific biology, and the specific neural architecture that your specific consciousness requires. It means that the fine-tuning is not merely a feature of the universe you observe, it is a feature of the universe you are. The fine-tuning is not out there in the constants, in the forces, in the abstract mathematical relationships between the parameters. The fine-tuning is in here, in your body, in your chemistry, in your neural architecture, in the specific biological machinery that converts the fine-tuning's physical consequences into the specific conscious experience that you are having right now. The fine-tuning is not something you study, it is something you embody, and the question of the architect is not a question about a distant designer, it is a question about the intelligence that produced you, the intelligence that is expressed, right now, in the specific configuration of matter and energy that constitutes your conscious experience. The physicist Paul Davies has described this personal dimension of the fine-tuning with precision. We are not just observers of the universe, we are participants in the universe. And the universe that we participate in is a universe that was exquisitely calibrated to produce participants. The fine-tuning is not merely a property of the universe, it is a property of the relationship between the universe and its conscious inhabitants, a relationship that neither the universe without consciousness nor the consciousness without the universe can explain. The recognition that you embody the fine-tuning has a specific, practical, existentially consequential implication. Your consciousness is not incidental to the cosmos. It is not an accident. It is not a byproduct of a blind, purposeless, randomly configured physical process. Your consciousness is the specific, improbable, extraordinarily precise consequence of a set of numerical values that the physics has measured, that the probability calculus has assessed, and that the contemplative traditions have perceived from within. Whether the values were designed, necessary, multiverse selected, or self-organized, the result is the same. You are here. You are conscious. And the universe that produced you was calibrated with extraordinary precision to make your existence possible. The philosopher Thomas Nagel, in his book Mind and Cosmos, argued that the existence of consciousness is the most significant datum in the philosophy of nature, more significant than the existence of matter, more significant than the existence of the forces, and more significant than the existence of the mathematical structure that describes them. If Nagel is right, then the fine-tuning's most significant achievement is not the production of stars, galaxies, and the cosmic web. It is the production of you, of the specific conscious being that perceives the stars, that studies the galaxies, and that asks why the cosmic web has the specific structure that the specific constants produce. It means that the question of the architect is not merely an abstract philosophical question, it is a personal question. The architect, whoever or whatever it is, produced you. The specific values of the constants that the architect established, or that necessity determined, or that the multiverse selected, or that the self-organizing process created, are the specific values that make your existence possible. The fine-tuning is not merely the foundation of the universe, it is the foundation of you, the numerical bedrock on which your body, your mind, your consciousness, and your entire existence rests. And it means that the contemplative practices are not merely techniques for personal well-being. They are instruments of investigation, instruments for exploring the question of the architect from the inside, through the direct perception of the intelligence that the fine-tuning implies. The physicist measures the fine-tuning from the outside through the instruments of experimental physics. The contemplative perceives the intelligence from the inside through the instruments of trained consciousness. And the question of the architect is a question that may require both perspectives, the outside and the inside, the measurement and the perception, the equation and the experience to answer. The physicist Freeman Dyson concluded his reflection on the fine-tuning with a statement that captures the appropriate epistemic humility. I do not feel like an alien in this universe. The more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. The universe knew you were coming. The constants were calibrated. The forces were balanced. The resonances were tuned. And the specific, improbable, extraordinarily precise set of numerical values that the physics has measured with its instruments produced, over 13.8 billion years of cosmic evolution, the specific, conscious, self-aware being that is reading these words and wondering whether the universe that produced it was designed, necessary, accidental, or something that none of these words can capture. The knowing is the paradox. The universe knew, but the knowing cannot be located. cannot be identified and cannot be attributed to a specific agent, a specific mechanism, or a specific cause. The knowing is in the numbers, in the specific values that produce the specific universe that produces the specific knowing. The knowing is in the consciousness, in the specific awareness that perceives the numbers and that recognizes, in the numbers' precision, the signature of an intelligence that the awareness itself may be. And the knowing is in the relationship between the numbers and the consciousness, in the self-referential loop that Wheeler described, in which the universe brings itself into existence through its own observation, and in which the fine-tuning produces the consciousness that produces the reality that the fine-tuning describes. The traditions call this relationship by many names: Brahman knowing itself through the Atman, the Dharmakaya recognizing itself through the Buddha, the Logos hearing itself through the creation's response, the Tao manifesting itself through the 10,000 things. Each name describes the same self-referential structure, the same circular, self-creating, self-knowing process in which the intelligence that designed the universe and the intelligence that perceives the design are recognized, ultimately, as the same intelligence, perceived from two perspectives. The paradox remains. The architect cannot be identified by the architecture, the designer cannot be found in the design, and the intelligence that the fine-tuning implies cannot be perceived through the instruments that measure the fine-tuning. But the traditions say the intelligence can be perceived through a different instrument, the instrument of consciousness itself, turned inward, past the measurements, past the calculations, past the probabilities, to the direct awareness of the intelligence that the numbers express, but that the numbers, by themselves, cannot reveal. The architect is not elsewhere. The architect is here in the specific values that produced the specific world, that produced the specific consciousness that is perceiving. Right now, the specific fine-tuning that made its own existence possible. The architecture is the architect, the design is the designer, and the consciousness that perceives the fine-tuning is the fine-tuning perceiving itself.